Welcome back. So we are asked here to find all solutions to the equation sine theta equals 0.8. So we know what that looks like on our graph, right? We can sketch a sine curve. We know our sine curve looks something like this. Whoops, not like that. Let's try this. There we go. And we know that if I put on the line here, call that 0.8, what we're looking for are all of these intersection points. Okay. So if we think about just one cycle around, we're looking for the first two, and then we know we can add 2 pi to get to the others. So let's think about this in terms of our unit circle. Unit circle-wise, what we're looking for are these two angles up here because they both have a sine of 0.8. So we're looking for this guy and this guy. And then we can add 2 pi to both of them. So here's the kicker. A sine of 0.8 is not a special known unit circle value. So what we're doing is we're saying, well, theta equals the inverse sine of 0.8. That's going to give me one value. Which value is that going to give me? Well, it's going to give me this one. Because remember that inverse sine is limited to the right-hand side of the unit circle. So let's go to Desmos. And let's take the inverse sine of 0.8. And I get that theta, equals 0.9273. Okay. I'm going to need Desmos back here in a minute. Let's just keep it up. So that is my first angle. That is this guy. How do I find the bigger one? Well, okay, I'm going to blow this up because I want to scribble on here. Okay. Here's the deal. This little angle here, and I'm going to clean this up a little bit. Okay. What we just found was this angle right here to be 0.9273. Symmetry tells me that this angle here is also 0.9273. Which means that I can find this angle from pi minus 0.9273. So one answer is 0.9273. The other answer is pi minus 0.9273. 2.2143, and these are again in radians. Now, I want all solutions. I currently only have the first two, so all solutions are 0.9273 plus 2k pi, or 2.2143 plus 2k pi, where k is any integer. The only real difference between this and the exact value problems that we did a few minutes ago is we use a calculator. However, we have to keep in mind the answers which we can get out of our inverse trigonometric functions. And to illustrate what I'm talking about, let's consider this problem. So let's find all solutions to the equation sine x equals -8/9 on the interval 0 is less than or equal to x is less than or equal to 360 degrees. So two complications here. One, we want our answers in degrees, so easy enough. I'm going to change my calculator into degrees. The other complication might not be quite so obvious. In order to make it clear what I'm talking about here, let's think about our unit circle. Now let's make our unit circle bigger. There we go. Where am I going to find angles with a sine of -8/9? Well, I'm going to find them here. And here, because sine is related to the y coordinate. So, and I also think about the fact that I want the positive angle. So I'm going to get this guy is one answer, and this guy is the other solution. What is inverse? And I know that what I'm going to do is I'm going to say x equals the inverse sine of -8/9. But before I plug that into my calculator, I want to think about what that's going to give me. Because what it's going to give me is this. It's going to give me, let's go ahead and do that, inverse sine of -8/9. I get -62.7 degrees. Whoops, sorry, -67.7 degrees. -67.7 is not between 0 and 360. So the first thing I have to do is add 2 pi to that to get the positive coterminal angle. So my first solution I'm going to find is, so -67.7 degrees is what my inverse sine gives me, but that's not in the right region, so I'm going to add 360 degrees. And I get 297.2, well, 0.3. That is the larger of those two angles. How do I get the smaller one? Well, remember that in absolute value, this angle is equal to this angle, which means this is 67.7 degrees. So I can get to the other value, the other solution, by adding 67.7 degrees to 180 degrees. So my solutions are going to be 297.3 degrees or 247.7 degrees. So the key here is you have to always be aware of the region over which you are searching for your solutions. And let's do one more example together, and then we'll be done with this section. So let's look at one more example here. And this one gets a little bit complicated, because it is an adjusted or a transformed trigonometric function. So let's say that we've got a rider on a Ferris wheel, And we can figure out the height of the chair and we find that the height of that chair is given by this equation. The height equals -65 times the cosine pi over 15t plus 70. And now the question is, how long is a rider more than 100 meters above the ground? Maybe you want to take some pictures. Maybe you've got a friend who's afraid of heights and you're trying to convince them to go with you. Either way, we want to figure this out. So if we think about graphing the height of the chair, of a given chair on a Ferris wheel, what we're looking at, we're given the equation, and it's -65 cosine pi over 15. I'm going to use x instead of t just because I'm in Desmos, plus 70. Now, I need to make sure that I put myself back in radians because my angle is in radians. And you can see what we're looking at here. Okay, now we want to know how long are we higher than 100 meters. So I'm going to bring this in so I can scribble on it. And all I really care about right now is one period. Actually, yeah, that'll work. Okay. What I'm looking for as I'm solving this, so we first hit 100 meters here, and we then go below 100 meters there. What I'm looking for is the difference between those two times. So in order to find them, I have to first find the times. So we're going to approach this just like we do any other equation. We're going to say 100 equals -65 times the cosine pi over 15 times time plus 70. Subtract 70 from both sides. And we get 30 equals -65 times the cosine of pi over 15 times time. Divide through by 65 and reduce it. So 30 over 65 reduces to 6/13 negative. Okay, now we know that -6/13 is not a special known unit circle value, so we're going to take the inverse cosine. So here's what we know. We know the inverse cosine of -6/13 equals pi over 15 times time. Okay, now I want you to pay attention to the order in which I do things. So the first thing I'm going to do is I'm going to take the inverse cosine of -6/13, and I get 1.8347 equals pi over 15 times time. Now you're going to be tempted here to just find your time. If you do that, you have to remember to determine the period of your function. And you can't use your unit circle because the period of the function that we're looking at here isn't 2 pi, like a normal cosine. It's 30, right? So here's what you want to do. What I generally do is I say let theta equal pi over 15 times time. So now I know that I've got 1 theta equals 1.8347. We're going to find my other theta because we remember that there are two values for which the cosine is negative 6 over 13. Here is 1. Here is the other one. We've got this guy as 1.8347. We find the other one. So how do I find the other one? Here's what you do. You realize that this angle here is negative 1.8347. But what you want is the positive coterminal angle. So you subtract that angle from 2 pi. And we'll use Desmos to do that. And we get 4.4485. Okay, so we've now got our two angles, but they're the angles on the unit circle. They're not our times. So what that means is that pi over 15t equals 1.8347, or pi over 15t equals 4.4485. So now we find time. We find time by multiplying both of those values by 15 over pi. So 15 over pi times 1.8347 means that time equals 8.76. (15 over pi times 4.4485 means that time equals 21.24. All right, so my problem isn't very well written because it doesn't tell me what my units are in time, but it's pretty reasonable to presume that these are minutes. So here's the answer. The actual answer is our change in time, which is 21.24 minus 8.76. On a good day, I might be able to do that in my head, but not today. So we'll subtract those two, 21.24 minus minus 8.76 is 12.48. And this is, you are above 100 meters for only 12.48 minutes. Which, if you're looking to take photos, may not be a very long time, but if you're scared of heights, it may be an eternity. So this is it for this section. I hope this has been helpful. Please reach out to me if you have any questions. Thanks. I'll talk to you soon.